straps. Wow.
Hello, family. Welcome back to Techsimple Drones Part 2. Shout out to everyone who viewed and commented the last video. I really appreciate that. Today we're going to dig a little bit deeper into Newton's third law and how it applies to drones. Have you ever wondered how you're able to peacefully sleep on an aircraft while someone obnoxiously eats crackers? It's because of Newton's third law. Your ability to walk down the aisle on the airplane and use the restroom while you hit someone on the aisle, that's because of Newton's third law. The ability of an aircraft to stay steady in the middle of the air while it performs a tedious task, that's because of Newton's third law. For example, drones are used for aerial photography, for photographers and films. It's used to ship things across countries. It's also used in the military for gathering information, or it's also used for like FEMA for supply and essential for disaster management. But drones and Newton's third law are very, very essential in today's world today. So today we're going to talk about net forces and how if the net force is equal to zero, what happens to the motion of an object? Or when the net force is not equal to zero, what happens to the motion of an object? And the two forces we're mainly going to focus on, the four flights of forces, are weight and lift. Okay? So let's look at another example of how Newton's third law acts with drones. Thank you. All right, y'all. So this is the video of a drone that's literally half a meter from my face. See, the power of Newton's third law is that it says every action has an equal and opposite reaction. And if the net forces of those forces are equal to zero, it's not going to move, vice versa. So you can see that the drone is literally stationary right now. So that means the net force is equal to zero. But then when it starts to move, the net force, depending on direction, is no longer equal to zero, it's equal to some number. And that's very significant because if I know one force, then I could pretty much find the other using a little bit of mathematics. So that's what we're going to learn today. What is the mathematical explanation of every action has an equal and opposite reaction? Okay, because if we can figure those things out, if we can figure out one force, we can figure out the other. If we can figure out the gravity, we can figure out the lift, we can figure out the drag, we can figure out how much is going against it. And that's the power of Newton's third law. All right, so it says calculate the lift of a stationary TELLO drone if the drone's mass is 225 grams. Okay, so when we look at this aircraft, we want to know that the forces that are on the aircraft, like the four forces of flight, gravity or weight, we have a lift. If I'm moving to the right, I'm going to have my thrust, and then opposite of my thrust is always drag. Okay, now Newton's third law says every action has an equal and opposite reaction. Okay, and if the net force of those objects is zero, then it's not moving. And if the net force is not equal to zero, then the object's moving. So we know that this is stationary, so we can assume that the net force, the total force on here is zero. Okay, so it's not moving either in the X or Y direction. So with that being said, we can figure out the lift of the TELLO drone if we know the opposite force. The opposite force of the lift is weight. So if we can figure out weight, we can figure out lift. Calculating weight, we will need the mass and the acceleration due to gravity. The mass is, according to this, is 225 grams. And we have to do this in SI units, so we convert that to kilograms. So that's 1, 2, 3 to the left. So 1, 2, 3, 0.225 kilograms. And my acceleration due to gravity, which is G, which is a constant, that is 9.8 meters per second squared. So if I want to calculate the weight, that's just going to be the force gravity or force weight equal to the mass times acceleration due to gravity, 0.225 kilograms times 9.8 meters per second squared. That's going to give me 2.4 newtons negative because this is pointing down. So my weight, the weight of the drone is negative 2.4 newtons. Okay, so that's about around less than 5 pounds. Okay, so next we want to figure out the lift. So if we know that the weight is negative 2.4 newtons, and we know that the lift is opposite of that, if the net force is equal to 0, Newton's third law says every action has an equal and opposite reaction. Okay, so the total net force in the y direction, because that's what we care about, is going to be positive FL, because it's pointing up, minus the weight. Okay, and we know that the total net force in the y is equal to 0. FL we don't know, but we know the weight is negative 2.4 newtons. Okay, so with a little bit of algebra, we can solve for the force lift by adding 2.4 newtons on both sides. And you can see that the force lift is equal to positive 2.4 newtons. So you can see here that the weight and the lift are both equal but opposite, which is Newton's third law. All right, so with that being said, I have a challenge for you. Calculate the lift of a TELLO drone if the mass of the drone is 245 grams. All right, if you have the correct answer, I will give you a shout out on our next T-Simple podcast called Science Literacy Part 2. Thank you all. I'll see you soon. Can't wait to see your answers. Please leave comments